All right, 7.7 notes, graphing sine functions, page 21 in your notes. Today we're going to connect the unit circle to the graph of the sine function, and then we're going to shift sine graphs. So a periodic function is a graph that repeats after a certain period in the domain. So notice this is a repeating graph, and so is this one. Those are the sine and cosine graphs. A period is one complete pattern. So notice it's starting at the bottom, it goes up, and then back to the bottom. So that's considered a period. The amplitude is the height of the graph from the x-axis. So from the x-axis to the highest point here, from the x-axis to lowest point here. If you were to draw a triangle inside the unit circle, where this is our angle theta, if it's the unit circle, then that means our hypotenuse is 1. This would make this the x-coordinate in the unit circle, and this the y-coordinate. So if you're looking for sine, sine is so O over h, so it's y over 1. So the sine ratio is equivalent to y, which means it's the y-coordinate in our unit circle. So if this is our unit circle, I'm going to label the 4 points that we learned about in 7.6. So again, if this is 0, 0, this would be considered 1, 0, going right 1. And then you have AO with a hypotenuse of 1. This is going up 1, so this is 0, 1. Left 1, negative 1, 0. And then down here at 0, negative 1. So at 0 radians, which is over here, we're trying to find the sine ratios. Sine is so, O over h. So that would be 0 divided by 1, which is 0. At pi over 2, that's at 90 degrees up here. Finding the sine ratio at this point, sine is so, O over h, so 1 over 1 is 1. Pi is over here at 180. Sine is so, O over h, so 0 over 1 is 0. 3 pi over 2 is 1.5 pi, so down here, sine is so, O over h, so it's negative 1 over 1, which is negative 1. 2 pi, notice that's all the way back around the circle, is again 0 over 1, which is 0. So notice we're repeating now. So we can just repeat the numbers in our table. So we have 0, 1, 0, negative 1, 0, because we just keep going around the circle. We're going to graph these points. So this is our x-coordinate in radians, and then this is our y-coordinate, the sine ratio. We're going to label it. So at 0 radians, the graph was at 0 for sine. Pi over 2 is at 1. Pi is at 0. 3 pi over 2 is at negative 1. 2 pi is at 0. And then 1, 0, negative 1, 0. So it's going to look like a curved graph like so. Notice the graph starts at 0, 0 and then keeps going. Notice though, if I went in the negative the clockwise direction, it would continue going this way. It's creating that wave pattern. So your domain, I could keep going around the circle all I want, so the domain is all real number. However, your range, or y values, goes from negative 1 to 1. A period, remember that's where the graph starts to repeat. So if you're starting here and you trace the graph, the complete graph ends at 2 pi. It takes a full 2 pi, which is a full circle around the unit circle. You're going to need to know that in a moment. Your amplitude, the height from the x-axis, is 1. And then since this is going through the origin, and we can rotate it around the origin and it'll match up, that means this graph is considered odd. All right, so to shift sine functions, the number in front of the sine ratio, if you take the absolute value, it will give you the amplitude. However, if it's a negative number, it's going to flip the graph on the x-axis. Your period, remember it was 2 pi around the circle, but that can change based on how many x's you have in your equation. So to find the period, you would do 2 pi divided by b, the number of x's. You'll have to memorize that fact. If you set the parentheses equal to 0, that will be your phase shift left or right. And then the number on the end, d, is your vertical shift up or down. So in the first example here, for our period, it's 2 pi divided by the number of x's. There's only one x here. So 2 pi divided by 1 is just 2 pi. Your amplitude is the absolute value of the number in front of sign. So the absolute value of 1/2 is 1/2. To graph this, we didn't have any phase shift left or right. There's no vertical shift. So that means I'm starting at 0. I'm going to end on my period. So I'm going to end at 2 pi. And you have to complete the scale on the bottom. This is the part that always messes people up. So halfway between 0 and 2 pi is just 1 pi. And then halfway between 0 and pi is half a pi. And then halfway in between pi and 2 pi is 3 pi over 2. There's a trick to this. If you add the numbers up and then take half, that's finding the average. So notice pi plus 2 pi is 3 pi, and then take half by dividing by 2. So to graph this, I'm going to scale the left side here. And then remember, sign starts at 0, 0. And then it goes up to the amplitude, back to 0, down to the amplitude of 1/2, and then back to 0. So that's one complete period for this graph. All right, number 4 says the same thing, state the amplitude, period, phase shift, and vertical shift, but this time we're also going to graph. So the amplitude is the absolute value in front of the sign, so absolute value of 1 is 1. Your period is 2 pi divided by the number of x's. There's only one x, so 2 pi divided by 1 is 2 pi. Your phase shift is when you set the parentheses equal to 0. So to get x by itself, you're going to add the pi over. So we're going to get pi for our phase shift. So it's going to shift the graph right pi. Your vertical shift is the number on the end. There is no number on the end, so there is no vertical shift. So to put this together, we're no longer starting at 0, 0 because we did shift the graph left or right. And in this case, we went right pi. So we start on our phase shift at pi. We end by adding our period. So I have to add my phase shift and my period to figure out where we end. So it's pi plus 2 pi, which is 3 pi. Now we can scale our axes. So halfway between pi and 3 pi is 2 pi. Add these up, take half. We're going to get 3 pi divided by 2. Add these up, take half. We're going to get 5 pi divided by 2. So then we can scale our axes. Sign starts at 0, 0. And then we're going to go to our amplitude 1, back to 0, down to the amplitude -1, back to 0. So there's our graph. For B, the amplitude is the absolute value of 1, which is 1. Your period is 2 pi divided by the number of x's. There's only one x, so it's 2 pi divided by 1, which is 2 pi. For your phase shift, you set the parentheses equal to 0. Solve for x by adding the 2 pi over. So my phase shift is 2 pi. And then your vertical shift is the number on the end, which is up 1. So putting this together, remember we have a phase shift, so we start at 2 pi. You end by adding your phase shift and your period. So 2 pi plus 2 pi makes 4 pi. To find in between, add them up, take half. So that'll be 3 pi. Add these up, take half. So we get 5 pi divided by 2. Add these up, take half. You're going to get 7 pi divided by 2. And then scale your side over here. Sign starts at 0, 0. Then you're going to go up to the amplitude, 0, down to the amplitude, 0. But don't forget your vertical shift. So from each of those points, I'm going to go up 1. That is going to be the graph. So in this problem for part C, what is the amplitude? Absolute value of 1 is 1. What is the period? So you did 2 pi divided by 2 x's, so you should get 1 pi. What is the phase shift? Setting this to 0, you should get negative pi over 4. I fraction busted by multiplying everything by 2 to make it easier. What is the vertical shift? That would be none because there's nothing on the end. So to put this together in the graph, you start on your phase shift. So we're going to start at negative pi over 4. And we're going to end on our period. So you add your phase shift and your period. So negative pi over 4 plus a pi, if I make a common denominator, is 4 pi over 4. And then you add them together, you're going to get 3 pi over 4. Now we have to find the number in the middle. So if I add these guys up and take half, if I add them, I get 2 pi over 4, which is just pi over 2. Take half, it'll become pi over 4. Halfway between negative pi over 4 and pi over 4 is 0. And then halfway here, if I add these up, I get 4 pi over 4, which is just pi, but then you have to take half. Scale the left side. Sine starts at 0, 0. You go up to the amplitude, back to 0, down to the amplitude, back to 0. There is no vertical shift, so that is our graph. All right, part D, what is the amplitude? All right, absolute value of the number in front is 6. What is the period? You should get 2 pi. 2 pi divided by 1x is 2 pi. What is the phase shift? Setting the parentheses equal to 0, you should get pi over 4. And then what is the vertical shift? You should get up 2, the number on the end. All right, so putting this together on the graph, remember you start on your phase shift, so we're going to start at pi over 4. And then you end by adding your phase shift and your period. So pi over 4 plus another 2 pi. If I get a common denominator, this would be 8 pi over 4 plus 1 pi over 4 makes 9 pi over 4. We have to find the number in between, so if I add these up, I'm going to get 10 pi over 4, which reduces to 5 pi over 2. Take half, that becomes 5 pi over 4. Remember, taking half is like multiplying the bottom by 2. So then, adding these up, I get 6 pi over 4, which reduces to 3 pi over 2. Take half, you get 3 pi over 4. Add these up, I'm going to get 14 pi over 4, which reduces to 7 pi over 2. Take half, so 7 pi over 4. Okay, so then we're going to scale over here. I can't count by 1 since my amplitude is 6, it won't fit. And I can't count by 2 because I have a vertical shift. So in this case, I'm going to count by 4. So starting here, going up, we have 4, 8, 12, negative 4, negative 8, negative 12. It is a sine graph, so that starts at 0, 0. It's going to go up to the amplitude of 6, which is between 4 and 8, back to 0, down to 6, back to 0. And then from those points, you're going to go up 2. So from each of these points, go up 2, up 2, up 2, up 2, and up 2, and then connect those points. That is your final graph.